Hello, I hope you're having a great day today. It's time for video 1G, and in this video we're going to review backtracking. Backtracking is a great method for solving equations. You may solve it a different way, but give backtracking a try. It helps us understand what the equations are saying, and it's good to have several different ways of doing something. Alright, here we go. So here are some equations that can be solved by backtracking, and we'll do a few examples just to practice setting them up. Like I said, backtracking is about understanding what the equation is saying. So we start by drawing kind of a t-chart here. I'm going to put x right there. I'm going to say what the equation is telling us to do with x. Our number x, we're looking for some unknown number. We're going to multiply it by 2 and add 17 and get 35. So we're trying to figure out what number does that. Alright, so we're going to write down the steps. We're multiplying by 2, we're adding 17, and we're supposed to end up with 35. So we're going to work our way backwards and see what it is we have to start with for this to happen. So if we take 35 and subtract 17 and then divide by 2, we should be back where we started with x. So we do this with our calculator. We do 35 minus 17 is 18. Divided by 2 is 9, so x must equal 9. And we could check it out. 2 times 9 plus 17 should equal 35. If you try it on your calculator, it works. 9 is the number that we multiply by 2 and add 17 to get 35. Alright, let's take a look at this one. So there's my t-chart. Now, start by focusing on x and what we're doing to it. So we're multiplying it by 6. It's kind of like order of operations. We have two things here, multiplying by 6 and adding 180. The way it's written, if we put a number in for x, let's say we put in 10, the first thing we do is multiply by the 6 here and then add the 180. Alright, so we're starting with x, we're multiplying by 6, we're adding 180, and it's supposed to end up being 306. So work our way backwards. We're going to take 306, subtract 180, and divide by 6. So if you do those steps in your calculator, you got to hit equals after every step. 306 minus 180, hit equals, divided by 6, hit equals, and it turns out that that's 21. Alright, let's take a look at this one. Usually if there's something with a fraction in it, people get scared, but this is no problem with backtracking. We just got to realize what we're doing. We're starting with a number, we're dividing by 4. Then we're subtracting 31. And it's supposed to equal to 72. So let's do it the other way. 72 plus 31. And then instead of dividing by 4, to undo it, we're going to multiply by 4. If you do those steps, you end up with 412. And that's the solution. 412 divided by 4 minus 31 is equal to 72. Okay, I want to do a couple more examples we can do with backtracking. Normally, you might distribute when solving an equation like this, and that would be fine. I'm just practicing backtracking here. So we can do this even without distributing, just by realizing the order of operations. Starting with a number x, because x minus 15 is in parentheses, we subtract 15 first. So we have x minus 15, and then we're multiplying all that times 2, and it's supposed to equal 26. So the order kind of here is important. Alright, so 26 divided by 2, that would be 13. We're going to add 15, that would be 28. Okay, same thing on this guy. Because of the parentheses, we're going to do the plus 49 first. So we have x plus 49 times 3 equals 99. And so we're going to do 99 divided by 3, and then subtract 49, and we should get, let's see what we should get. We should get negative 16. Alright, very good. This one, this is kind of odd one. This division bar is kind of like a grouping symbol. It's almost as if we have parentheses there. If we put in a number for x, we'd have to add 6 first and then divide the whole thing by 7. Okay, so here we go. X, we're adding 6 first, then we're dividing by 7, and we're supposed to end up with 12. So we go backwards. We're going to do 12 times 7 minus 6. If you did that, you should get 78. All right, try this one. Again, all of this is in the numerator, so that comes first. So we have x, and then we're going to subtract 13. We're going to divide by 4, and it's supposed to be 68. So do 68 times 4. It's a times there, not a minus. Sorry about that. I'm going to do plus 13, and you end up with 285. No problem. So backtracking can solve a lot of equations. So that's why I like it. If you kind of understand what the equation's saying, this works really well. And people remember backtracking pretty well. There is one kind of dangerous situation here, and there are these problems. So yeah, this is the one type of thing you have to be careful, and it's just being aware of what you're doing here. A lot of people look at this equation, they think that 90 is being subtracted. That's not true. It's 4x that's getting subtracted. The minus kind of goes with the 4. In fact, we could write this as adding the opposite as plus a negative 4x equals 22. That really emphasizes that we're multiplying x by a negative 4. All right, and we're really the 90 is positive. It's just sitting there, and we're adding it. Okay, if we understand that, then we know how to set this up. So it's x, we're multiplying by negative 4, and we're adding 90, not subtracting it, equals 22. So we'll do 22 minus 90 divided by negative 4, and we get 17. Okay, so once we realize that negative, think of it as going with the 4, then this works out great. So on this one, think of this as multiplying x by negative 6. So times negative 6 plus 28 equals 70, and we have 70 minus 28 divided by negative 6, that's division, and you get negative 7. Again, you can think of this as adding the opposite, plus a negative. All right, before we go, I just want to take a look at two geometry problems. This is geometry after all. So here's two situations where solving equations come up. In this figure, the total distance from A to C is 47. Okay, so 47 equals. That has to be what we get when we add up AB right here and BC. When we combine those two pieces together, those two lengths are supposed to equal the total length, 47. So we can say 47 equals 3x minus 12 plus x plus 23. Now, we have to combine like terms and simplify this a little bit. So 3x plus x is 4x. And a negative 12 plus 23, well, that's just plus 11. And now we can backtrack. Okay, so we had to simplify a little bit, but we got that. Times 4 plus 11 equals 47. Oops, 47. So we're going to do 47 minus 11 divided by 4, and you should end up with 9. Okay, so 9 is the number that makes that work. All right, last one. You've been great hanging in here for this. Here's another situation, this time with angles. So there's really one step of geometry here, realizing the relationship, and after that it's algebra. Well, this angle plus this other angle here, they form a straight angle. That means that they must add up to 180 degrees. And that is the fact from geometry that gives us an equation. 5x plus 26 plus 4x plus 10 is equal to 180. All right, combine like terms. We can put those two together, 9x. We can put the 26 and the 10 together, plus 36 equals 180. Okay, I'm going to skip the backtracking. If you do this, you get x equals 16. Now sometimes they might ask you to go back and find the angles. So you could substitute 16 in for x, and I believe you get this angle would be 106, and this one would be 74. Okay, so I didn't this time just find x, but they could ask that as well. All right, time for the moment you've been waiting for. Here it is, your journal assignment. So copy these 3 equations down and solve them. Hopefully you can use backtracking to do it, but if you want you to do it a different way, that's fine. And here's one from geometry, very similar to what we did. So remember, these 2 angles form a straight angle. So those 2 angles have to add up to 180. Okay, so write an equation, solve it, see you in class.